Hey, what's going on, Antioch Bears? Mr. Crawford here. Going to talk a little about sigma notation this time. Sigma notation comes from this Greek letter sigma, from the Greek alphabet. And you'll hear it sometimes referred to as summation notation. The key part of that is the first three letters of the first word, sum. In mathematics, the word sum means add. It means the same thing if you see this symbol. If you see the sigma symbol, they're asking you to add some numbers. I'm going to write it again down here. And just kind of go over the basic layout of it. At the bottom of the sigma symbol, you will see what's called an index, or a starting point. It might be something like n equals 1. At the top, you're going to see the ending point, maybe a number something like 3. So starting point, end point. And it's important to remember that this n equals 1 as the start doesn't necessarily refer to the number 1. It refers to the first position in line, something you might think of as A1. Remember A1, A2, A3, and so forth. The number there might be 1, or it very likely might be something else. Off to the side of sigma notation, you're going to see the rule. The rule may be something along the lines of -4 times 2 to the power of n minus 1. This is just one example of a rule. There are many more. If you think about in terms of adding numbers, what they're really asking you to do is to take the number in the first position, the number in the second position, and then the number in the third position, the end point, and add them all up. In order to do that, you must first identify who is first, second, and third in line. And you identify them by using the rule. We're going to start with the index where n equals 1. We're going to plug 1 in for n here in this exponent expression. 1 minus 1 makes 0. This is where it's important to remember those exponent rules from Algebra 1. Anything to the power of 0 actually equals 1. It only refers to the 2 inside the parentheses, not this -4 out here. So he's going to come down, and the base 2 raised to the 0 power is 1. If you're ever unsure about something like that, by the way, the most common wrong answer is 0. People just assume it's 0. Always check with your calculator. It definitely knows the rules. Finally, -4 times 1 is -4. That tells me the number sitting in A1, or the first spot in line, is -4. I'm going to go ahead and make places for the other two that are coming. Now we must find who's in the second seat, A2. We do that by moving our index up 1. Now instead of n equaling 1, we've already figured that out. Now we're going to make n equal 2, and then eventually 3, and then we know we can stop. This is telling us the end up here. Two minus 1 makes 1. 2 to the first power is still just 2. And -4 times 2 is -8. So sitting in the second seat is -8. Finally, we're going to go up to 3, our ending point. -4 times 2 to the 3 minus 1 power. Remember, I just keep rewriting this rule over and over again, replacing n first with 1, then with 2, then with 3. I get -4 times 2 to the power of 2. 2 squared is a +4. And -4 times +4 is -16. So here I have the first 3 terms of this sequence. I hope you recognize, since we've been talking about it, that this is a geometric sequence. It has a common ratio, or an r. It's being multiplied by 2 every time. So if we wanted to imagine what A4 is, we're just going to multiply this by 2. We'd get -32, so on and so forth. But we don't need that for this. The sigma notation is telling us to add the numbers sitting in positions 1 through 3. So 1, 2, and 3. So we're going to add -4 plus a -8 plus a -16. -4 plus -8 is -12. -12 plus -16 is -28. Again, it's important to use calculators to check yourself if you're unsure. It's kind of frustrating as a student, I know, that you do all this wonderful algebra work correctly and then you make a minor mistake when you're adding or subtracting integers and you get the wrong answer. So double check with a calculator if you're ever unsure. So the whole thing could be shown as this. This was the answer we got up here from doing this work. Now, that was pretty easy to do if you have 1 to 3, but suppose you had 1 and your ending point was supposed to be 500. You certainly wouldn't want to do this 500 different times. There is a formula that has been discovered that I'll teach you guys next time. Have a great night, Bears. See you tomorrow.